So here we have a definite interval. Got the upper and lower limits, 0 and 4. The integral, though, I have to do is square root of 2x plus 1, which, you know, if I rewrite that with parentheses, would be 0 to 4, then 2x plus 1 to the 1/2 dx, which that, again, square root of 2x plus 1 is not the square root of 2x plus the square root of 1. Okay, if you're thinking that, no go. Can't do that. You're stuck with the square root of 2x plus 1, or 2x plus 1 to the 1/2. So yeah, this is one we have to do with a simple u-substitution, I like to call it, but it is a u-substitution nonetheless. Use that parentheses expression, 2x plus 1. Then you need the du. Du would be derivative of that, 2 times then dx. And then I can go ahead and solve for dx. That's du over 2 is my dx. So I've got u to the 1/2, and then dx is du over 2. And so I'm in good shape as far as the antiderivative is concerned. But what I'd like to point out now is these limits are in terms of x, right? When I start with, this is x is 0, x is 4. Well, now that I've gone to u's, they still are in terms of x, these limits. So that's the first point here about these definite integrals is when we change over to u's, unless we change them, these limits are still in terms of x, okay? So keep that in mind. Like I said, the antiderivative now is pretty easy because that's just 1/2 divided by 2 is 1/2, and then the u to the 1/2, the antiderivative would be, the new power would be u to the 3/2, so it'd be 2/3 up front of that. And I don't need the plus c because this is a definite integral I'm going to evaluate. However, again, these are in terms of x, so can I substitute them yet into that? No. That's still u. These limits are in x, so we still, if we do it this way, we still need to go back to change that back to x's. The 2's cancel. Change that back to x's, which is 2x plus 1 to the 3/2. Now we've got a place where we can substitute those x values. See what I'm saying? So that's 1/3. Plug in the 4 there. You have 2 times 4 plus 1, that'd be 9 to the 3/2. And then subtract 1/3. Plug in the 0, that would be 1 to the 3/2. So that's what we would evaluate. Leave 9 to 3/2 would be 27. 1/3. 1 to the 3/2 is 1, so it's 9 minus 1/3. 8 2/3 or 26/3. Okay, so yeah, you got it. In the definite integrals, you got to make sure you plug it in the right place. All right, so here's another one of those. What about integral 5 to 8? Square root of x minus 4 times 15x dx. Well, again, let's rewrite that. Square root of x minus 4 is x minus 4 to the 1/2. That's 15x dx. And our u substitution is just x minus 4. So du would be 1 times dx. So in this case, yeah, sometimes du and dx just are one and the same. In this case, du is dx. So that would just be 1-to-1 substitution here. All right, let's see what that makes this. So the x minus 4 is the u, so that'd be u to the 1/2. 15x, I didn't do anything with that yet. And then du is dx, so here's what I've got. And again, since I'm doing the upper and lower limit thing, these are x's, not u's. So make sure you notice that. But we still have a problem, don't we? Problem is, when I do my u-substitution here, in this case there's no cancellation, I still have an x. Now, we talked about just a second ago, in some cases having an x is bad, but that's if you've got, in the way I'm doing it, if you've got an x in the denominator du. We don't have that problem here. This is an x on, if you will, the side of du. So that problem can be fixed by just going back to the original equation here. Solve that for x. Be u plus 4 is my x. So I can substitute u plus 4 for x in that equation. In that interval. X is u plus 4. And so now do you see how I can do this? Now I can just go ahead and multiply this 15u to the 1/2. Go ahead and multiply that into that parentheses there. So I'll have, that'd be 15u to the 3/2 plus 15 times 4 would be 60u to the 1/2. Now I can do this. All along until this point, I've had times. This times this, this times this, this times this, this times this. Now I don't have time. I just have this plus this. So that I can do the antiderivative. Let's see, the new power would be 3/2 plus 1, 5/2. So don't forget to multiply that by 2/5. This would be 60. The new power would be 3/2, 1/2 plus 1, and then a couple times now, so do have to multiply by 2/3. We don't need the plus c because we're doing a definite interval, but it is x's, 5 and 8. Cancellation, that would be 3, so this would be 6. U, but again, I need to plug in x's, so I need to go back to x's. U is x minus 4. That 3 will go into that. So I have 40 u to the 3/2, but go back to x and be x minus 4 to the 3/2. And so finally, I can plug in those values because I got my x values. Let's see, that would be 8 minus 4, so that would be 4 to the 5/2. 6 times it, this would be 40 times 4 to the 3/2. And then I'll plug in my 5. Well, 5 minus 4 is 1, so that'd be 1 to the 5/2 and 40 times 1 to the 3/2. Well, that'll be square root of 4 to the 5th. Square root of 4 is 2. 2 to the 5th is 32. Plug in your calculator if you want. That would be the square root of 4 cubed. Square root of 4 is 2. 2 cubed is 8, so that would be 40 times 8. And of course, 1 to anything is still 1. So it looks like I've got 6 times 32. Is that 192? Plus 320 minus 46. Whatever that is. 466, yeah. That's what I had it before. 466. Question?